Hello everybody, welcome back. Ranger Greg here. It's a pleasure to have you back in class. Last week we explored broad features that determines the presence of different climates on this planet. Different features giving different abilities to plant and animal life. So today we're going to take it up a notch and try to explore a little further about how these climates impact plant adaptations. Perhaps plants created their own climate too. I don't know, I wasn't around. Were you? Last week's assignment was to find plants illustrating the different climates. So here's some of the findings of the students. As you can see, there's a high diversity of plants that were found in backyards, front yards, alongside boardwalks, and even indoors as ornamental plants. Today, we're going to look at what makes these plants so adapted to these different climates. You'll also see that some of the features present in one climate is also valuable in other climates, but you'll see later. I'm going to give you a rough overview of some of these adaptations that allow plants to grow specifically in some climates more than others. Let's start with...
It's way too cold.
The coldest parts of this globe are located closer to the poles, respectively with the Arctic in the North Pole and the Antarctic at the South Pole. Closer to these higher latitudes, we have a whole range of areas that have also very harsh conditions, just like harsh winds, extreme temperatures, sometimes even complete absence of light. So you can only think that you need to be severely adapted to survive in these climates. Evergreen trees, grouping all conifers just like pine trees and fir trees, commonly called Christmas trees, have specialized leaves called
Needles!
needles. And needles are very thin, tightly packed, and they're easier to drop. Since they have less leaf surface, they also lose less water, which is an advantage when you have a strong exposure to the sun, or to high winds, or very low temperatures. So you want to be as concealed as you can. Another advantage that these guys have is their shape. It's kind of like conic shape, where the snow is easier to fall off. Because if you accumulate too much snow, the weight might damage your branches, and you don't want that. You want to stay safe and strong. Another way to save energy is just to stay small. So this is typically found in very harsh conditions, either very hot or very cold, or areas with strong wind exposures. Look how tiny these guys are, you can barely see them. Speaking of small, the expert at saying small are called lichens. A combination of fungi and algae that work together to make one of the most resistant species on this planet. They are growing on rocks, just like this one. And they're part of the primary colonizers, meaning they're colonizing a space first, creating organic substance for other species to come and tag along, basically. But these guys can survive the harshest conditions, from coldest to warmest. And some of them are even an indicator of clean air. Doesn't look like it, eh? Pretty tough guy. Subtropical and tropical. Tropical and subtropical regions of this globe are the zones that are the closest to the equator, that get the most sunlight, but are not necessarily the hottest parts of this world, because there is the presence of large bodies of water, like oceans. So there's a lot of evaporation, right? You come on sunlight to water, water rises. So there's a lot of upward convection and a lot of precipitation, which allows a gigantic biodiversity to establish itself. Other plants invested a lot of energy to create broad leaf structures with what is called a drip tip. So as you can imagine, the water falling here is directed downward. So the water doesn't actually stay on the leaf, because having a lot of moisture, there's a risk for fungus or bacteria to establish themselves. And you don't want that. Okay, you want the water to flow away. Some of them also have like a waxy surface, which increases the capacity to let the water run off. Some took the easy option, the lazy option, and decided not to invest as much energy into producing a solid stem. Instead, they're investing quite smartly into little structures that allow them to grasp everything that encounters their growth. And these plants are called vines or lions, just like this passion fruit. Equally as smart, having a smooth bark, having a smooth trunk, allows the trees to get rid of such viney species. They're just slipping off. How cool is that? Humid and temperate. The temperate zone of this planet is equally as fascinating. It is located between the polar latitudes and the subtropics. These zones experience 4 seasons that are distinctly different throughout the year. In 1 year, you can have a zone that experiences Arctic conditions up to subtropical conditions. High winds bringing in warm and cold air. You can only imagine how adapted plant life needs to be to face such alternative environments. Deciduous plants are very common in this climate. Because think about it, it's all about saving the most energy possible. So you want to have as many leaves as you can during the effective sunlight period, meaning the spring and summer, and you want to drop unnecessary stuff when it comes to harsh conditions, just like this one. Do you feel me? Storing nutrients in the root system and saving nutrients for later, especially during the harsh months, is also a very effective strategy. When you are a low-growing species, you need to find a smart way to access sunlight. So just like this fern, you want to be as wide as you can to capture as much sunlight as you can, but still be discreet and find your place, right? How humble. Cutie. High and dry. The driest places on Earth are located 30 degrees south and north from the equator. And in these zones, the evaporation exceeds the precipitation, which means that water is scarce. There's a second type I wish to include in this category, and they're called Mediterranean zones. And they're basically located on the west side of continental masses. West side! So, these climates are characterized by wet and cold winters, as well as very dry and hot summers. So, as you can imagine, that forces the flora to be quite versatile and resilient. So, here are some of these adaptations we can find in broader, dry, and hot climates. If water is scarce, you want to find ways to store water efficiently. So specialized tissues allow some of the plants to store water, just like this jade plant and this cactus. Accessing water appears to be at the forefront of priorities. So they have a vast root system that extends far beyond their trunk to reach water sources, to maximize the water collection. Very squishy, very nice. Another way to make sure that you survive in harsh conditions is a waxy surface that limits the water evaporation. It kind of works like a plastic wrapper, just like this aloe plant. A clever feature that allows plants to limit their water loss is to have thin, tough leaves that also collect the moisture when it drops. They're pretty pokey. Another good way to limit the evaporation of water is by having a protective color. White reflects unnecessary sunlight, just like this succulent. Others are covered in hair, just like this phacelia, that reflects sunlight and also captures moisture. Just like this lavender and other plants of the same family, called the Limiaceae, like rosemary and thyme and sages, produce oils that are not that attractive to animals. So it limits their herbivorous action, meaning they stop eating from it, which allows them to save nutrients and save energy. They might smell well, but not for everybody. A good way to limit herbivorous action is to make really tough leaves, just like this native oak. Not so very tasty. A good way to dissuade some herbivorous people or animals is to have thorns. You know, you just don't really want to get too close to that. To my right, a palm tree. To my left, a native pine. We can see in these two cases that they have adaptations that are available in very cold climates and very hot climates. The thick bark in the palm tree protects the trunk of losing too much water and for water to increase its temperature. So it's kind of like a protective layer. Same thing as the pine in cold climates, where the bark protects from outside low temperatures of actually freezing and damaging transport channels. In both plants, we have a very deep root system, which allows them to access the deepest water tables. In the palm tree, well, to access water that is scarce, and for the pine, accessing water beyond the frost zone, which also destroys roots and damages water transport channels. As you can see, there are many different strategies that plants found to grow and thrive. So I want you to notice yourself next time when you're procrastinating, complaining, or simply wishing that the conditions were different about the teachings of these plants, teaching us to do the best we can with what we have. Now it's your turn to work. As we saw, we have certain features that are very adapted to very specific climates, and others are actually present in more than one climate. I want you to make a list as exhaustive as you can, listing all the features that are present in more than just one climate. Task number 2, make a list of the different strategies that plants found to control the water, either escape, intake, or access. List, as best as you can, water-related adaptations viewed in this video, and if you have additional knowledge, please share too. Third task, I want you to take a self-portrait, commonly called a selfie, with a plant of your choice. But hold on, you're gonna write on a sheet of paper or some kind of other support what you share in common with that plant. Can be color, can be texture, can be an emotion, can be a basic need, can be a physical feature that you might recognize yourself in, like, ooh, I'm all orange today. Up to you. This was Ranger Greg. It was a pleasure to have you in class. I'll see you next time. See you all. Sir.